Hello once again. This is the first part of our new series where we will be creating a space simulator. In this part we will focus on moving our spaceship. We will see how we can make it move, apply forces to it, and we can fly around. And the next parts we will see what else we can do. So the model is from BlendSwap. You will find download a link to BlendSwap below in the description, so you can download it or follow along, or if you have your models you can use those. And the scripts are based of the ones you will find inside vehicles in the packages you already have. It's not going to be exactly the same, but it's heavily based on those, so if you want, write along or just download them and do the changes from there. So after you drop the spaceship, but keep in mind the scales over here, because the forces we are applying will have a significant effect depending on the scale of the spaceship. So if I scale this up, it will start behaving a lot more different, a lot more slower, as you see here. So let me just make it the way it was. I think it was something like this or this. Anyway, so after you drop it, make an empty game object and add some colliders over there. We don't want to use a mesh collider because it's more taxing on our performance. So after you made it cover all the areas you want, and drop for now our main camera to our cockpit, so somewhere so you can see. Don't worry about that. Later on we will see how we will make the camera rotate with our mouse, and we will actually make it as it is in games like Star Citizen, where you can get off the cockpit and move around your ship and cool stuff like that. Okay, so let me just delete the scripts so we can start to rewrite them. You can add a rigid body either from here or from our script, and we want the angular drag to be at 4. As I said, this of course depends heavily upon the scale and how big is your spaceship. So I'm gonna name the first script Spacecraft control, and of course, since this is a spaceship, you don't want to use a gravity. And I'm going to open my script. Let's just add the required component type of rigid body from here, just so that you don't forget it. And I'm going to delete start, we don't actually need it for now. And let's start by adding our variables. Now, a lot of variables will have a technical term, so if you go and Google that, you can get a better description of what actually is and what actually is in the real world. Okay, it's not going to be totally realistic, but it's going to be enough, and it's going to, for our project, it's going to be just the thing we want. So max engine power, you can understand, it's the maximum output of our engine. These values, of course, is for the scale of my own spaceship, because I've tested them. In your spaceship you might want to test them and see the appropriate values. So the roll effect is the strength of the effect for a rolling. You will see later what rolling is exactly, what the roll effect is. The pitch effect is the same, just on a different axis. The yaw effect, you can Google that to get a better explanation. Also bank turn effect, you can also Google that. This have a lot to do with physics and aerodynamics, or however you call them. This is basically taken from, it's almost the same as the ones that Unity gives you. So if I'm going too fast, it's because you can watch it from there, or you can Google and see what everything does. Now, our auto roll, wherever you see auto, it means that we are manipulating the values. So for instance, our auto turn pitch, it's how much our spaceship will automatically pitch when we are inside a bank turn. And the roll level, it's how much our spaceship will try to level when we are not rolling. So it will actually kind of correct its position. Auto roll level, auto pitch level, the same as above. We want a float for our air brakes effect, then we give it a value of 3, and we want another float, which is our throttle change speed. And we need one over here, which is how much we change the drag. Now let's add some private variables. You can understand the throttle is how much of the throttle we use right now. If we have our air brakes on, how fast the spaceship is traveling forward, this actually is the same, yes, because it's the same as the above, we get this error, so we call it we might not even need this, but let's just keep it because I might have forgot it when changing the default scripts. Nope, not your input, we want a throttle input, and over here we want some other floats. We want our original drag, we want our original angular drag, this we can use this if we want our spaceship to be immobilized, so if we're taking hits or if we hit an asteroid or something else, we can override the controls. And of course we want a reference to a rigid body, and we want colliders over here, although the script has it as wheel colliders. We will just use an array of colliders over here, and then so on start, of course the first thing we want to do is get the reference to a rigid body, and then original drag equals rigid body dot drag, and original angular drag equals rigid body angular drag. And now we want a for loop that will get us all colliders from inside our transfer. And the way we do this is, of course, first we get the child count with a for loop, where is it? And we do for each, var, let's give it a name, components in child in transfer dot get child I dot get component children collider. So components in child dot yeah, that is why they used a wheel collider. So let me just see wheel collider calls. Oh yes, let's change this to a wheel collider because they are accessing the motor torque. Components in child dot motor torque equals with an 0.18 f. So let's just leave it, since they already have it like that, let's just not mess with it, since it's already working. There's no reason. So let's create first our move function, and we want this to be public so we can access it from our user control script. So we want to take a float, it's a roll input. We want to take our pitch input, our yaw input, yaw, however you call it, our throttle input, and a bool for air brakes, and I think that's enough. Yes. So, or maybe, yeah, so that we don't confuse it. Now the first thing we of course need a roll input, our roll input with capital R, which is actually, let's make it this roll input so we don't confuse ourselves. This dot roll input is this variable over here. Okay, it's not this. We just simply take this and insert it over here. We have done this before. So our pitch input is this pitch input, our yaw input is this yaw input, and this dot throttle input equals throttle input, this dot air brakes equals air brakes. So we will add more stuff over here. Let's just go, before we do that, let's just go and make our helper functions. So the first thing we want to do is to clamp our inputs, and we want to clamp them between -1 and to 1 range. So our roll input equals mathf dot clamp roll input -1 1. Our pitch input equals mathf dot clamp pitch input -1 1. Pith I have it wrong, so let me just fix it. Your input equals mathf dot clamp your input -1 to 1, and our throttle input equals mathf dot clamp mathf dot throttle input -1 1, and that is a clamp input. So let's take it over here and put it inside our move. So the next function we're going to use is, of course, we want to calculate are roll and pitch angles. So let's call this function calculate roll and pitch angles, the same as is the same name as it's in the standard scripts. So first off, we want to calculate a flat forward. And a flat forward means we don't want to calculate the y, so we just manipulate it and make it to be at 0. So if the flat forward dot square magnitude is greater than 0, we want to normalize that. We want to calculate our current pitch angle. And pitch angle equals mathf dot attenuation to our local flat forward dot y local flat forward dot z. So this calculates us our pitch angle. Let me delete the space over here so that we have it more organized. And now we want to calculate our roll angle. So vector 3 flat right equals vector 3 dot cross vector 3 dot up and a flat forward. The vector 3 dot cross is the cross product of two vectors. So the cross product of two vectors results in a third vector which is perpendicular to the two input vectors. Okay, you can find this is trigonometry. You can find a lot if you want to learn more for this. You can find, I think in English it's called vector math. So anyway, Google and you can find anything you want. So vector 3 local flat right equals transform dot inverse transform direction flat right. So a roll angle equals the attenuation of a local flat right dot y and a local flat right dot x. And now that we have a calculate roll and pitch angles, let's go up and copy paste the function in our move function. So next off we want a function which is our auto level. So we want to work with our banked turn amount, which is banked turn amount, and we want mathf dot sin roll angle. So now the scene in cine, how you write it anyway, is a mathematic it's a trigonometric function of the angles. More on that on Google, your friendly neighborhood Google. So we want to say if roll input equals 0, roll input equals minus roll angle multiplied by auto roll level. So if there is no input if there is no roll input, it just automatically corrects the roll. You might not want to use this in your own games. You might want to use it to enable autocorrect the roll and the pitch on specific cases. You can do whatever you like. I'm just keeping it because it's a nice effect. So next, for our pitch input, if pitch input is at 0, we want pitch input to be minus pitch angle multiplied by our auto pitch level, and our pitch input to be minus equals the absolute value of the current bank turn amount multiplied by itself and multiplied by auto turn pitch. So we have the auto level. Insert the function to move, and let's move to the next function. So now we want to calculate the forward speed of our plane. So we call it, the function we will call calculate forward speed. This we need the vector 3, which we will call local velocity, and this will be transform dot inverse transform direction rigid body dot velocity. So we store our own velocity, and our forward speed we want the maximum value between 0 and our local velocity dot z. Okay, mathf.max simply returns whichever value is greater. Next function, let's just copy paste this also in our move so that we don't forget it. So next off, we want of course to control our throttle. If we are mobilized, we want of course to override our throttle input, and we give it 0.5 minus 0.5. But if we're not, we want our throttle to be mathf.clamp 01, and that will be a throttle plus a throttle input multiplied by time dot delta time multiplied by throttle change speed. So this will make it, this will adjust our throttle based on our throttle input or if we are immobilized. And the engine power is of course the throttle, or throttle change speed is the throttle multiplied by maximum engine power. Copy the throttle, this function, and paste it inside the move function just so that we don't forget it afterwards. And next we want to calculate the drag. So we want to increase the drag based on the speed, and since this is a constant drag, yeah, so in the notes of the standard assets it says we want to increase the drag based on speed, since the constant drag doesn't seem to be real, so go figure. So yeah, a lot of this stuff, as I said, is from the standard assets, and it's made from people that know better physics than I do. And yeah, you know, games like Star Citizen, they have a bigger team and seamlessly endless resources. Okay, so don't bother yourself so much with them. We are doing it just by ourselves, so we will take any resources we can use and we will use it, and that's a promise. So rigid body dot drag equals, if our air brakes is true, we want our original drag plus our extra drag, and all this multiplied by air brakes effect. But if it's not, if the air brakes, we don't have the air brakes, we want our original drag plus the extra drag. So of course the forward speed will affect the angular drag. You know, if you are running 100 miles per hour, you can't turn as fast as you will turn if you are running with 5 miles per hour. So this is calculated by the angular drag, and of course our angular drag will be our original angular drag multiplied by the forward speed, but since this will be a very big value, we subdivide it by 1000. You might want to go lower, you might want to go higher, you will see how much, what it works for you. You probably might even want to change according to the ship, change this value according to the ship, the current ship. So a big Star Destroyer or Death Star, you know, it won't turn as fast as an X-Wing. So we have finished with this function, so let's drop it over there. Next off, next function, we want to calculate our linear forces. and we want forces. So we take a 0 vector 3 and we start adding the engine power multiplied by a transform dot forward, and to the end we just apply it to our rigid body. Let's go to our function over here and paste our new function. So the force we apply over here is, as you can see, the engine power multiplied by a transfer forward. Our engine power is controlled by our throttle and the maximum engine power, and so on. And the last function for this script, or probably the last big function for the script, the other two are easy. So we want to calculate our torque, and we will say we will start with a 0 vector, and we will take the torque and we will start adding pitch input multiplied by pitch effect multiplied by transform dot right. Next, we want to add to the torque vector as and the yaw input multiplied by the yaw effect multiplied by transform dot up. Next, we want the torque to start adding, and we want roll input multiplied by a roll effect multiplied by transform dot forward. And last, we want to add the bank turn amount multiplied by bank turn effect multiplied by transform dot up. And of course the total torque is multiplied by our forward speed, so the controls will have more effect at high speed and little effect at lower speeds. So we calculated all the torque, and the last thing we of course want to do is add torque to our ship. So torque multiplied by our aero factor, and we have calculate torque. So we drop the function over here, so into our move, and the last two functions we will need is two public functions, so that we can use them without having to access the booleans, which this will simply make the immobilize to true, and we want the reset of course, which makes the immobilize, and something's wrong, which makes the immobilize to be false. So now that we have all our functions over here, let's go to our move function. So now, because we are supposed to be in space and there is no gravity, when there is no throttle, even if we keep moving and we stop giving the throttle, because there is no gravity and there is no friction, the spaceship will keep moving forward. So of course we don't want to do that. We want to see some more, to have more control over it, since this is a game. So we can say if the throttle is less than 0.1, then we want our current velocity, restore our velocity. We want to calculate the new velocity, which is our current velocity multiplied by time dot delta time. And lastly, we want our rigid body velocity to be our current velocity minus the new velocity. New velocity. And that's about it for this script. Save, go back. Of course, if we drop this over here, and let's see where is the error. Mobilize. Let's see why there is an error. Yeah, we have, instead of mobilized, we have immobilized. And let's make sure there is no, yes, okay, it's all correct. Yeah, instead of having the variable, I had the function. This will fix it. Yes, of course, this over here, even if we hit play, it doesn't do anything. If I enable gravity, of course we fall to the ground, but since we don't want it, so let's start controlling our spaceship. But before we do that, I'm going to go project settings, and on input I'm going to add a new axis, which actually is going to be the same as the vertical, the same values, except negative button, which is how you will reduce the throttle, will be the X. Positive button will be the Z. Okay, name, I give it the name of throttle. Gravity will be at 3 and dead will be at 0.001, and sensitivity will be at 1. Type key or mouse button, axis, x-axis, and get motions from all joysticks. Okay, since we'll be using and this is a space simulator game, okay, so I'm guessing everybody will want to play with a joystick. So in the way you can do this, you can simply add some more axes over here and give it the same values, the same name, so you can have 50 axes named horizontal and different negative and positive buttons. Okay, I don't have a joystick, so I can't show you that, but it's not going to be so different. Now, if you want it to be for mobile, I think Unity has already some cross-platform input. Okay, so I haven't tested because I haven't do so much work with mobile. So Google for cross-platform input, and I think this has to do and with consoles and stuff like that. So anyway, let's go. Let's name this user input. Let's drop it from now into our spacecraft control. Let's open it. So the first variable we will need is easy, and you can guess what it is. Is of course spacecraft control. And we want, actually we don't want. So on start, what we will do, we of course going to add the reference, set the reference to our spacecraft control component, and then we don't want to use the update, but we want to use the fixed update. Let me delete that and that. So inside our fixed update, we want a float for our role, which of course this is our get axis, horizontal. We want a float for our pitch, which is our vertical axis. So with this, A and D will make the spacecraft roll, and with the pitch, the vertical, W and S will make it either go down or up. So we will add a bool for our air brakes. Let's just give it, let's just leave it as it is in the standard assets, which is the Fire 1 mouse, the left click. We will later on later videos we will fix all that, and we will make some more we will make a lot of adjustments over the scripts, but since I don't want to just say download the scripts, because then we might have problems, because I won't be able to know what you changed or what you didn't. So this will actually help us a lot. So our throttle, we want to be our throttle axis, and of course now that we have all our axes, the only thing we need to do is spacecraft control dot move and pass our values. Throttle and air brakes. Now they gave the yaw. Anyway, the 0, I don't remember what it does, so let's just keep it like this. If it works, it works. So now that we have our user input, and if we hit play, we can start with WHD. Let me make it side by side view so that you can see or hopefully you can see what I'm doing. So we are moving with WASD. We move the spacecraft around. Of course, as I said, you might want to play with these values over here so that you can have whatever you want and the controls you want, but for me these values seem pretty responsive. So now that we have, and if I hit Z, you can see that I'm actually start moving. And if I go very fast, it takes a little before changing the direction we are moving. So if I just had it keep giving the direction, if I was just adding a force to the rigid body to go forward, we wouldn't have this effect. Okay, so, and when I'm moving and if I hit click, I'm braking, hitting the brakes, and you can do some cool stuff with it. I have the ground over here so that we can see that we are moving and see what we are doing. It's going to be in space in the end, but before we create our universe over here, I wanted to have something to just not get confused that we are not moving and stuff like that. So that was it, about an hour. Yeah, so next part we will actually start working inside our spaceship. It won't to be the most I don't have the interior of a ship, so I will show you how to do it with some models I have on my hands. But you can use, and if you model the ship, you can have your modeler model the exact same inside of the ship, so that you have some more nice effects and you can create a better experience. I'm just showing the all videos I'm doing over here should be taken as a gospel, okay? I'm just showing you examples of what you can use, what you can do with all this, and I actually lost my spaceship. So thanks for watching. Next week we will do our third person shooter, and the week after that we will resume to this. I'm doing it 1 week, 1 tutorial 1 week, 1 series 1 week, and 1 series the other week, so that I can have some more time to really work with everything we have, and we're actually making some progress. So thanks for watching, and to infinity and beyond.